Hello, everybody. Michael from FUTO here. Today we're interviewing Ian Clarke about some new changes and features that are happening on the Freenet project called Ghost Keys. So FUTO recently gave a follow-on grant to Freenet for $200,000, and we're always excited to hear about new and interesting developments happening on the project. So if you wanted to just briefly introduce what Freenet is, just briefly for people that don't necessarily know coming into this video.
Yeah, absolutely. So Freenet is software that a project we started 25 years ago, but for the past couple of years, we've been working on a new version of it. And the fundamental idea behind Freenet is that the internet as we know it today is really dominated by a handful of companies, and it's an extremely centralized system. And the goal with Freenet is to create an alternative to that, where instead of companies like Google and Microsoft having all of your data and having all of the control, it decentralizes the control so that you can build systems of really all the different types that we have on the internet, but which are completely decentralized.
Yeah. So did you want to, so you just added Ghost Keys. Can you tell us a bit more about what this is? There's also a blog post on freenet.org if you want to read more about this. So.
Yeah, absolutely. So Freenet is an opportunity to really revisit a lot of the most fundamental aspects of how the internet works. And there were a lot of almost original sins in how the internet was designed. And one of the great things about Freenet is we really get to re-examine those and see if in 2024, having learned the lessons of the past half century of internet, if we can do better. And one of those, I suppose, original sins of the internet relates to the idea of trust, and specifically negative trust. And the issue is that bad actors on the internet can do bad things like send spam and create bots that manipulate social media for all kinds of nefarious purposes. And if you catch them, all they have to do is switch to a different IP address or a different account, and the bad reputations don't stick on the internet. And this has given, I think the very first spam email was sent in 1979, and it's been getting worse ever since then. And this fundamentally comes down to this problem of negative trust. Now, with the internet today, because it's centralized, there are things like spam filters, there are things like CAPTCHAs that everyone pretty much hates.
Yeah, they're extremely annoying.
And which frankly don't work. It's actually, if you look at the economics, companies like Google make CAPTCHA technology available to people. My understanding is what they charge for a user to fill out a CAPTCHA is less than what you can pay a Russian bot network to compromise the CAPTCHAs. So not only are CAPTCHAs extremely annoying, but they don't do the fundamental thing they're supposed to do. So the internet, people have tried to come up with these solutions, most of which don't work very well and are very annoying for users, and particularly if maybe you're if you have eyesight challenges, for example, CAPTCHAs are pretty bad news. And so instead of us all kind of failing to be human, being told that we're not actually human by CAPTCHAs when we don't get them right, I really wanted to revisit this problem. And then the second issue is that because Freenet is totally decentralized, in many ways it makes the problem potentially worse because it makes it even more difficult to identify bad actors and try to block them. And so this is the problem we're tackling head on with ghost keys.
Yeah, so in a decentralized situation where you don't have any central authority that you can call back to say, like, this person is a bad person, this person is not, like certifying people, you have to come up with some alternative way or reputational system that works in such a way that you don't need that central authority to, like, calling all these shots on people. Like, individuals within the system themselves, like, essentially give reputation in some way to other users to like certify them individually. So how does this work in ghost keys?
Yeah, absolutely. So ghost keys, it's actually quite simple, and that's very important because transparency is pretty critical for a system like this. So to get a ghost key, you go to the Freenet website and you make a small donation to Freenet. The smallest amount is just $1. And our website verifies the donation transaction, and then afterwards, your web browser will generate a public-private key pair within the web browser. And we can talk a little bit about what that means. But think of it as a key that's generated in your web browser. It then takes the public part of that key and blinds it, essentially encrypts it, and sends it to our server, which signs the encrypted public key. It's then sent back to the browser, which unblinds it, and what it gets is a digital signature of the public key. But the critical thing is that the server never actually saw the key itself. The server only ever saw the blinded key, which means that you now have a cryptographic key that has been authenticated by our server and tied to this donation. It's a certificate that says the owner of this key has made this donation to Freenet, but there's no way for us or anyone else to tie that donation transaction to that key itself, and so that preserves the anonymity and privacy of the user.
So we could talk a little bit more about these blind signatures. So my understanding is that this is very similar. It's kind of like an old school throwback to the Cypherpunk type of reputational systems, or like old school cryptographic constructions like Chaumian digital currency or digital bearer certificates. And in those situations, this is kind of zero knowledge proof. It's kind of like a proto zero knowledge proof. Is that what you would call it?
Yeah, absolutely. So I think it was 1982 that the first blind signature algorithm was proposed. So this is not a new technology, and that's kind of a good thing, because if you're using some bleeding edge is not a good thing when you're talking about cryptography. But maybe we could start with just asymmetric cryptography and explaining that a little bit. So there are different broad categories of encryption algorithm. Probably the simplest is symmetric cryptography. And symmetric cryptography means that if you and I want to communicate privately, we first need to agree on a key, which is just I don't know how many bytes, short amount of random looking data that we would agree on, and then we can use a symmetric cryptography algorithm. I use the key to encrypt the message I want to send to you. I send you the encrypted message. You can use the same key to decrypt it, and anyone monitoring our communication isn't able to see what we're saying unless they have the key.
So with symmetric cryptography, you're just doing it in this like kind of way where you both have access to it, and with an asymmetric system, it's kind of like the public key, private key, Diffie-Hellman type constructions.
Exactly. Yeah. So private key cryptography. There are kind of two ways it's used. It can be used. The first is encryption, and so the idea there is you would have a public key and a private key. I would too. If I want to send you a message, I need your public key. Your public key, as the name suggests, anyone can know that. That's fine. I can use your public key to encrypt a message and then send it to you. And the critical thing is that you can only decrypt the message with the private key. And so this solves the problem with symmetric cryptography where we need some way to communicate the key privately. With asymmetric cryptography, that problem goes away because it doesn't matter who knows the public key. The second way that you can use asymmetric cryptography is for digital signatures. And the way that works is we each know each other's public key. I can use my private key to sign a message and then send it to you. In this case, it's not being encrypted, so anyone could read it, but it could also be encrypted. But I send you the message with the signature. You can then use my public key to verify the signature. So you know that this message was written by me and not somebody pretending to be me. So you have the kind of encryption thing you can do, and then there's the digital signatures and signature verification. With blind signatures, it takes it a step further. So the idea with a blind signature is you want me to sign a message using my private key, but you don't want me to know what the message is that I'm signing. And so with the blind signature algorithm, and there are a variety of them. Again, the first were created in the early 80s. But with the blind signature algorithm, you take the message and you blind it, which is effectively a kind of special type of symmetric encryption. So you encrypt it and then you send it to me. I sign the encrypted message, so I never see the message itself. I don't know what I'm signing. I send that back to you, and then using the blind signature algorithm, you can take that signature and, in effect, unencrypt it. And now you have a digital signature by me of this message, but I never saw the message itself. And so this is the fundamental technology that allows ghost keys to work.
One analogy that I've heard before that I think might make it easier for people to understand watching this is like, maybe you can think of it like a letter in an envelope. So like I have a letter that is encrypted, and then I close the envelope, and then I hand the letter off to you, and then you can like sign the outside of that envelope, certifying that letter in some way or stamp it or something. And then imagine it's like maybe like carbon paper where you write on the outside and it's shown on the inside. Mm-hmm. Then after I open up that letter, the signature that you wrote on the outside is then imprinted onto that letter that was inside after I open the letter. But you, when you sign it, cannot open the letter paper. You can only sign what's inside of it. Is that
100%.
a good?
Yeah. Absolutely, 100%. And so the way, and you mentioned zero knowledge, so there's a kind of there's a relatively new, very hot area of cryptography at the moment called zero knowledge proofs, and this is, I don't know if it's technically zero knowledge, but you might be able to say it was the first example of a zero knowledge encryption algorithm. Would that be fair?
It's a bit similar, but I don't know if it's
technically.
Yeah, it's maybe not technically the same, but it has a similar principle behind what you're trying to do. But we don't have to go into the complexity involved in those.
Zero knowledge is about 400 times more complicated to explain. So let's not dive into that. But the way that ghost keys use the blind signature is that you make your donation to Freenet. Your web browser will create an asymmetric key pair, just right there. It'll take the public key, the public part of that key pair, it'll blind it, and then it'll send it to our server, which will verify that the donation happened and then sign it. And what it's actually signing it with is we have a master signing key, and then we have what we call delegate keys. And each delegate key basically says this delegate key was created on this date, and the owner of the key pair that's been signed by this delegate key donated $1 or $5 or $20 or whatever the amount is. And so your web browser then is able to construct a cryptographic certificate that contains your signed public part of your ghost key, and then it also contains the delegate certificate that will say how much you donated, and it will also say when that delegate key was created. So in principle, systems could be designed to say, well, and we haven't really got into the applications yet, but you can use that information in the applications. For example, if it was something quite important and you wanted a high degree of trust, you might say, well, you can only do this if your ghost key, if it's $100 ghost key instead of a $1 ghost key. But the system itself is very flexible. It doesn't care how you use it. But people building things on top of the system can specify criteria, which could include the donation amount.
So you talk about the donation. So other than just what it is being a donation to the Freenet project, the monetary aspect of this plays a role in the security of the reputation system. Can you go into a little bit more about how that monetary aspect plays into it?
Absolutely, yes. So the reason we're doing this should probably mention. So the reason we're doing this is we essentially want people to have skin in the game with this public-private key pair, because normally you can generate key pairs as much as you want. Like depending on the type of key pair, it's virtually instant. So what we want is to essentially give the user some skin in the game with a key pair. A key pair can be used in a wide variety of ways, but one of the ways it can be used is as a reputation. And so this is a way to, in effect, bootstrap a reputation with a small amount of money. That's essentially proving that you just didn't create 2 billion of these, or if you did, it cost you at least $2 billion, which would be great if anyone would like to do that. But so yeah, it's a way to bootstrap a reputation in the system. Because one of the ways that the reputation system can work is that, let's say if you and I were going to interact in some way on Freenet, and so a simple example might be you want to send me something like an email, and I don't want to get inundated by spam, and so I configure my inbox to say only people that have a ghost key with a good reputation can send me emails. And so in order to send me an email, you would need to sign the message with your ghost key. And when you send the message, you would also attach your ghost certificate, which would essentially proves that it's a real ghost key associated with a real donation. And then let's say I receive the email and you've just sent me spam. And so you've kind of betrayed my trust in a way. Part of how this mechanism would work is that part of the certificate that you send is what would be called a feedback key. And a feedback key would give me the ability to attach some negative reputation to your ghost key that anyone else could see. So think of it as similar to how if you buy something from somebody on eBay, after the transaction is complete, you're able to give some feedback on them that other people can see. So this is a cryptographic way to implement something akin to the eBay feedback mechanism, but of course it's much more general purpose than that.
Okay. And so in theory, if a key has enough negative reputation, then it's basically like that $10 that you donated or whatever is now becomes worthless if you get a negative enough reputation. So to combat the spam, you're essentially saying if you spam on something that you paid money for, you're burning that money. You're burning that key. And then this is the protection mechanism?
Exactly. So you're creating a cost. So the reason that the spammer business model works is that they can get access to your attention effectively at essentially zero cost. And so as soon as you create a cost for doing that, you destroy their business model. Whether it's spammers or whether it's bots that are perhaps manipulating social networks, all of these things only work because they can steal people's attention on a massive scale with very little cost.
And so this web of trust that you're forming here, so we talked about like one of the applications that you could possibly use this for, but unlike other webs of trust, like PGP servers have a web of trust system going for them, but you can't do a whole lot with this except for email, for example, to like certify like, yes, this person is who they say they are because of some arbitrary non-reputational web of trust. And so you just talked about email could easily be used for this, but like what are some other applications? Like what kinds of things can I vouch for another person for with like a key in this kind of system? Or do you imagine that it could be used
Yeah. So maybe we could explain the term web of trust in case people aren't familiar. Yeah, so the web of trust idea, as you said, it goes back to, I think, at least the early 90s when PGP did it. PGP was an early tool that allowed you to use asymmetric cryptography to both encrypt and sign email. And it's, I guess one of the things that makes it interesting is that it never really gained broad adoption. And so it was one of the early examples of a long line of tools that give people much better security, but which nobody used because they were, I won't say nobody, but people like you and me used it, but they did not gain mainstream adoption because they were difficult to use. And so I use PGP as kind of an example of how there's no point in creating tools that give people great security if they have to compromise on usability, because if they have to compromise on usability, nobody will use it, and then it doesn't matter how clever the cryptography is if nobody's using it. But one of the ideas in Pretty Good Privacy was, or one of the problems was, how do I know that what I think is your public key is actually your public key? Because if I want to send you a message and I get your public key and encrypt it, well, if it turns out that that was actually some attacker's public key, they can then read the message and you can't. So what PGP came up with was this idea of web of trust, where if you and I meet in person, like we're doing right now, we could exchange our public keys and know for a fact that this is your public key. Which is great, but the problem is it's not really practical for everyone to meet everyone else in person. So with Web of Trust, it uses transitive trust. So you and I might meet in person, and so I know your public key is yours, and you know mine is mine. You might meet someone else in person, and you guys can verify your public keys. But because I trust you somewhat, and you trust that other person, the Web of Trust system will say, well, okay, now I have some degree of trust for this other person. Maybe not as much trust as I have for you because we actually met in person. And so this is where the web in Web of Trust comes from. But like I said, the PGP really struggled to gain broad adoption because it was just difficult to use. There's a long history to Freenet, which I'll try to avoid getting into too much. But the first version of Freenet, we're now working on the sequel to the first version, but the first version of Freenet, we built a system like Web of Trust on the original Freenet, and it was primarily a spam, whereas with pretty good privacy, that was mostly about verifying that people's public keys belong to them. With the original Freenet Web of Trust, it was a spam prevention measure, and a very, very effective one, actually. With the new Freenet, because it's really a blank slate, we're working on a much more general Web of Trust system, because there are different types of trust. Like I might trust my doctor to prescribe medication, but I might not trust them to fix my website.
Yeah.
And so there are different types of trust. So our goal for this new Web of Trust is to recognize that fact, but and so there are different types of trust. You can trust. I might trust you not to spam me, for example, but I might not necessarily trust you to hold on to $500,000 on my behalf. I'm sure you're perfectly trustworthy, but not trying to cast aspersions, but just that there are different types of trust, and so so we're building this Web of Trust system that accounts for different types of trust. But with any system like that, you need a way to bootstrap a reputation. You need a way to just initially create the reputation, and that's where ghost keys come in. A ghost key is a way to bootstrap a reputation that can then form part of this global trust network and can be used for all kinds of different things.
And you're writing the ghost key code base in a way where ideally it would be generalizable to a multitude of different applications, like you're talking about, not just like email spam. So like
100%. Yeah, we've really tried to design it. Our design goals were keep it simple, make it so that it's extremely easy to use, or it can be extremely easy to use, so we don't have the same problem as PGP where normies don't use it. And then the other goal with it is to make it as general purpose as possible. So we don't assume it's being used for email. We don't really assume anything. It's just a public-private key pair, and then what we've created tools that allow people to verify their key and to sign messages. So we've created a command line tool that you can install very easily, and it'll let you do things like take your ghost key that you after you make the donation and all of this magic happens, it just presents you with the ghost key in the browser, which you can cut and paste and put it somewhere safe, like maybe a secure note in a password manager that you trust. And then our command line tool will let you do things like you can sign messages, you can verify signatures, and so on. But more importantly, we've also created a Rust library so that it's very easy to integrate this into other systems, and in particular integrate it into Freenet contracts so that it plays nice with Freenet. But actually, even if Freenet didn't exist, ghost keys would still be a useful idea. So it's not kind of completely tied to Freenet, although it is very symbiotic with Freenet.
I see. Okay, so unless there's anything else, go check out the post about the ghost keys. The Rust library's up. There's like example code for how to like test this and play around with it. Yeah, check it out on freenet.org. So yeah.
Thank you very much.
Yeah.